All right, today we're going to crack open Python's programming toolkit. We'll dive into the essential tools every developer needs, from the humble function all the way up to the powerful class, and see how choosing the right one can make your code not just work, but actually last. So let's dive right in.
But let me start with a question for you. Is your code really built to last? I mean, come on, we've all been there, right? Scrambling to write some code that just works for the moment. But how do we go from code that just works to code that's organized, reusable, and efficient? The kind of code that you, or maybe someone else, can easily understand and build on months or even years from now.
Well, the secret really is all about mastering the fundamental tools Python gives us. And that's exactly what we're going to do today. Think of it like we're building your very own Pythonic toolkit, a set of go-to tools you can pull out to solve specific problems and write some truly elegant code.
All right, first tool out of the box. It's the absolute bedrock of organized programming, the function. You can think of these as your essential power tools for creating reusable blocks of code.
So, what exactly is a function? Well, think about it like a recipe. You don't write down the entire recipe for baking a cake from scratch every single time you want one, right? No, you write it down once, and then whenever you need a cake, you just follow that recipe. That's exactly what a function does for your code. It packages a specific task so you can use it again and again.
And making one? Super simple. You just use the def keyword to define it, give it a name, and then you write the code you want it to run. And if you need to get a result back from it, you just use the return keyword to send a value back out. Okay, and here is a super cool Python trick that I just love. Functions aren't stuck returning just one thing. You can actually send back multiple pieces of data just by separating them with commas. Python is smart about this. It automatically bundles them up into something called a tuple, which is kind of like a fixed list. Then you can easily unpack that tuple back into separate variables. It's a really clean way to get like a result and maybe a status update all from one single call.
All right, let's grab our next set of tools. So you've got your data. Now you need a place to put it. In Python, two of the most common options are lists and arrays. Now, on the surface, they might look kind of similar, but trust me, choosing the right one can have a massive impact on how your code performs.
So, it all boils down to this one big trade-off: flexibility versus efficiency. On one side, you've got your trusty Python lists. Super flexible. You can throw anything in there. Numbers, words, other objects, you name it. But on the other side, you've got arrays. Now, they're a bit stricter. They demand that everything inside is the same numeric type. And while that sounds like a drawback, it's actually their secret weapon.
I mean, just look at the numbers here. If you store 1 million integers in a regular Python list, it can take up about 28 megabytes of memory. But an array holding the exact same data? Only about 4 megabytes. So why the huge gap? Well, a list has to store a ton of overhead for each item. Like, hey, what type of thing is this? An array doesn't bother with that. It knows everything's the same, so it just packs the raw numbers right next to each other. Super, super compact.
And that right there, that's the impact. That's an 86% savings in memory just by picking the right tool. For anything data-heavy, that's a total game changer. And it's not just about saving space. The benefits just keep on coming. When you start doing math, the difference is, honestly, it's kind of staggering. Doing a calculation on 1 million items takes a list 2 whole seconds. The array, it does it in 1/10 of a second. That is a 20 times speed up just from making a smarter choice about how you store your data.
Okay, so we've got tools to package our code, functions, and tools to store our data, lists and arrays. So what's next? What if we want to bundle the data and the code that works on that data together? Well, this is where we level up to methods and classes.
Come on, you've typed this out 1 million times, right? You've got a list, you hit that little dot, and you call a method like .append. That dot, it's actually a really big deal. It's a signal that we're not just calling some random function, we're calling a function that is specifically attached to our list object. And that really leads us to a super simple but powerful definition. A method is just a function that belongs to an object. It's designed to work specifically with that object's data. That's it. And this right here is where programming in Python starts to get really fun and powerful. I mean, using built-in methods is one thing, but the real magic kicks in when you ask yourself, wait, can I make my own objects with their own special methods?
And the tool for that job is the class. Simply put, a class is your blueprint for creating your very own types of objects. It's how you bundle together the data you want to store and the functions, the methods that are supposed to work on that data, all in one tidy package.
You know, the classic analogy here is honestly the best one. Think of the class as the architect's blueprint for a house. It spells out the whole design, how many bedrooms, where the kitchen goes. An instance, then, is the actual physical house you build from that blueprint. And the cool part is, you can use that same blueprint to build tons of houses, tons of instances, but each one is its own separate thing.
All right, so we've got our heavy-duty construction tools down. Now let's look at more of a finishing tool, something that adds elegance and makes our code more, well, Pythonic.
And that brings us to the Lambda function. I love thinking of these as little throwaway functions. They're anonymous, so they don't even get a formal name, and you just whip them up on the fly for a single quick job. The one big rule is, while they can take a bunch of arguments, they can only do one single thing, one expression.
So let's see what that looks like in practice. Here's how you'd normally write a function to cube a number. You use def, give it a name like power, and you have a return line. Pretty standard, takes up a couple of lines.
And now, here's the Lambda version. See that? It does the exact same thing, but it's all packed into one single, elegant line of code. It's just perfect for those little jobs where a full function feels like a bit much.
So there you have it. We've pulled some of the most important tools out of our Pythonic toolkit. But remember, the most important skill of any craftsperson isn't just having the tools, it's knowing exactly which one to grab for the job at hand.
Okay, so let's do a quick recap of our toolkit. Got a piece of code you're using over and over? Make it a function. Need a flexible container for all sorts of different data? A list is your go-to. But if you're dealing with huge amounts of numbers and you need speed and efficiency, that's a job for an array. Want to invent your own objects from scratch? You're going to build a class. And finally, for those tiny in-the-moment calculations, a slick little Lambda will do the trick.
And that really leaves us with a big question to think about, especially looking towards the future. As AI gets better and better at actually writing code for us, is it possible that the most valuable skill will shift? Is it going to be less about the nitty-gritty of writing every single line and more about being the architect, the one who knows exactly which tool to tell the AI to use? It's definitely something to chew on as you keep honing your own skills. Thanks for tuning in.